Okay, so let's try to understand uh, with this diagram. Okay, so this is a vector A and this is the vector B. Let's say. So what is this theta? Well, theta is the angle between A and B. Okay, such that this A and B are joined together by tail to tail. Okay, so this is it. Now, this dot product also follows some rules, some identities. So let's discuss it one by one. First is the commutative rule. So A dot B is equal to the B dot A. Of course, it has to be equal. Uh, uh, you know, these are this magnitude of A and magnitude B of B, and this cos theta are the scalar quantity. So we can just exchange it one after the other, and the result will always be the same. So in this way, this dot product can be justified. I mean, the commutative law can be justified. It also follow the distributive law. Okay, so just like here we have distributive law for the scalar multiplication of the vector, we will also have the distributive law for the dot product, like the A dot B plus C. I mean, either we will add two vector and take the dot product with A, or we can take the dot product of A with the first vector B and sum it with the dot product of A with the vector C. Both will give the same result. Okay, so let's understand what physically this dot product actually means. Okay, what is this equation? What is it is telling us? So let's draw the same diagram and one more times. So we have this B vector and here we have A vector. Okay. Okay, so let's write this A dot B is equal to the this magnitude of A and magnitude of B times the cos theta. So what is this theta? Of course, theta is this angle. Okay. So what we can see that the A cos theta is equal to the A dot B divided by the magnitude of B. So what is this cos theta actually representing? It is representing this vector. This is actually the projection of A over the B. This is the A cos theta in the direction of this B vector. So what cos product actually does? I'm sorry, what dot product actually represent physically? So what it does, it says that the dot product of A and B is nothing but the projection of A over the B times the magnitude of B. Okay, so this is this vector is the projection of A over the B, and when we multiply it with this with and when we multiply this projection A cos theta with the magnitude of B, that that final values is represented. Yeah, I mean that final value represent the dot product. Okay, and one thing is that this A dot B will be 0 for the case when when you know for the three cases, A dot B will be 0. That means A dot A, I mean magnitude of A, magnitude of B into cos theta equal to 0. But we have three cases. Either this will be 0, either this will be 0, or either this will be 0. Okay. So either A vector will be 0, B will be 0, I mean their magnitude will be 0, or cos theta will be 0. So cos theta will be 0 if the theta is 90 degree. That means if two vectors are perpendicular to each other, then means their dot product will be 0. And physically, what that means is that this vector is not showing any projection over this vector. And that is why their cross product, the dot product will be 0. Okay. Let's come to the third kind of multiplication for the vector, which is the cross product. So the cross product is represented by A cross B. Okay, we don't use dot over here, we use the cross B, and their value is you know A vector, B vector times sine theta. But the result of this cross product of A and B will not give a scalar value. So this is the scalar value. We have to introduce a direction. Okay, so let's say this is the n direction. So this the cross product will give another vector. Okay, so what is this? The value of this another vector will be this. But direction is, let's say, n. So what is this n? We will see from the geometry. So here we have this A vector, and here we have this B vector, and of course the angle is theta. Here instead of cos theta we will see the sine theta over there. What is this n? So this n is actually, okay, see, so A and B will form a plane, okay, or we can say A and B, or we can say that A and B, let's say this, A and B will live in a plane. Okay, see this green boundary is nothing but a plane, and n vector is perpendicular direction to this plane. Okay, so we have this plane. Okay, and n direction n cap is the perpendicular to this plane. So the n vector will be represented by this symbol. Okay, it is coming out of the plane. Okay, come to the come to the properties of this cross product. The first properties is the distributive properties. Okay, the, uh, there is a reason because this cross product do not follow the commutative properties like let's be like A cross B is not equal to B cross A. Okay, but you can say that from this equation we can say A cross B or B cross A, these are the scalar quantity, so they can interchange their position. So the final result will give A cross B and B cross A the same value. But we are not getting over here. Why? Because there is this n cap vector. Changing the A cross B and to B cross A will change this n vector. I mean the direction of the final vector, because this is going to represent a vector. So the direction of the final vector will not be the same in this direction.